Hello students, welcome to KENE'S Educare, a group of KENE solutions. This is part 1 of lesson number 11, Work and Energy. So as you all know that part 1 is always the introductory part for the lesson, right? So here I will be making you aware of all the terms that we are going to study in the lesson work and energy, so that when we are discussing it further, you at least have a bit information on work and energy, right? So I will be starting my introduction. I'll be discussing all the basic concepts. I will be letting you know what are the parts that we are going to study in the lesson. But before that, work and energy is something that you all have studied it for before, as in your earlier grades as well, right? So I want each one of you to please write whatever information you have with respect to work and energy. Like you might be knowing some or the other thing, some or the other definition, SI unit, anything with respect to work and energy. Just write that down in your book so that you are also aware of that, you know this all things, and you will be like elaborating it further, right? So I'm giving you 2 minutes. Everyone, please write whatever you are aware of with respect to work and energy in your book. I hope every one of you are writing it. So while you were writing, you might have realized the information that you have with you, right? So see, now in this chapter 11, okay, work and energy, we are going to discuss on the concept of work, energy and power in detail. So there will be many new things that you will be like studying with respect to work and energy in detail, because in our day to day life we consider any useful physical or mental labor as work, right? Even if you are mentally doing anything, that has been considered as a work. If you are physically doing something, that is obviously a work, right? But scientifically, if you study, work is different, like work is defined differently over here. Okay, now how can I define scientifically? So work done by a force acting on an object is equal to magnitude of the force multiplied by the distance moved in the direction of the force. Okay, so like you will not understand whatever I told you now, but once I like let you know more other parts with respect to work. And remember one thing, like this should be in your mind every time whenever I say work. Work has only magnitude and no direction. Okay, what does work has? Work has only magnitude and no direction. Okay, so similarly, we often use the term energy in our daily life, like work is very common, right? And energy is also one of the term which we often keep on using in our daily life. So like work had a different definition scientifically, energy is also like different in science, like the definition is different for energy in science. Like if I say about physics, in physics energy is the quantitative property that is transferred to a body or to a physical system. What is energy? It's the quantitative property that is transferred to a body or to a physical system, recognizable in the performance of the work, and we get the conclusion or result as in the form of heat and light. Getting it, everyone? So like I want you to write few points from this, like work has only magnitude and no direction. This was one of the important statement. Then you can write that energy can only be transferred from one, you can say one form to another. We cannot create energy, neither we can destroy it. So energy is very important, right? So these are two important statements which I want you all to take in book. Everyone please be quick. I hope every one of you are writing it. See, now what is work? Suppose you have an object in front of you. So whatever work done on an object is, how you are going to define that? See, work done on an object is defined as product of the magnitude of the force acting on the body. Okay, what I said? Product of the magnitude of the force acting on the body and the displacement in the direction of the force. So the formula for work will become W is equal to product of the magnitude of the force acting on the body and displacement in the direction of the force. Now we represent displacement as small s. So the formula that we will get for work done on an object is equal to, product means multiplication, right? So product of the magnitude of force acting on an object and displacement in the direction of the force. So if you know this formula, you can easily define work done on an object. It's the product of the force acting on the object and displacement in the direction of the force, and we get the formula as W, that is work done, is equal to force into displacement. Okay, so I want you all to write this thing in your book. Like, you need to write work on an object is defined as, from there you need to write this, and you need to know that the SI unit of force is Newton. What is the SI unit of force? It's Newton. Okay, so be quick everyone and write, take that in your book quickly. I hope every one of you are writing the definition on work done on an object. After like we are done discussing about the work done, the next thing that we need to discuss is energy. Now let's say if I like tell you to run 50 kilometers, run 50 kilometers, do you think after running, now 50 kilometers is too much, right? So after running 50 kilometers, do you think that you will be able to do any sort of work? If yes, well and good. If no, what is the reason? Why you won't be able to do like any work once you run 50 kilometers? So the reason is actually that you won't have that energy, right? So when we discuss on energy, or when you have to define energy, energy is defined as the ability to do work. What is energy? The ability to do work is energy. And the SI unit of energy is going to be the same. But remember one more thing about energy, that energy is a scalar quantity. Okay, what is energy? Energy is a scalar quantity, and the SI unit of energy or work is joule, or you can even say as Newton meter. We know that work done is the SI unit of force is Newton, right? So when it comes to energy, the SI unit of energy or work is joule, or we can even write Newton meter for it. Got it, everyone? So we can write Newton, where N will be capital and M, that is meter, will be small. So I want you all to write the definition for energy quickly. Energy is defined as the ability to do work. Okay, and the SI unit of energy or work is, either you can write as joule or you can write as Newton meter. Okay, and one more important point about energy is a scalar quantity. What is energy? It's a scalar quantity. So please take this points on energy, everyone. once you're done writing the energy, like we will be discussing on different forms of energy, because there's not only one single energy, there are different forms of energy that we have, right? Okay, so now we have different forms of energy to discuss. Like we have light energy. We won't be discussing them in detail. It's just that you need to know that there are different forms of energy that exist. Okay, so we have light energy, we have heat energy, we have chemical energy, electrical energy, and even we have mechanical energy. So we I want you to write this five forms of energy that we have. I'm repeating it again: light energy, heat energy, chemical energy, electrical energy, and mechanical energy. Okay, just write these types of energy and then I'll explain you one more part with respect to it. See, when you write mechanical energy is going to be the sum of two different energies. And those two different energies are kinetic energy and potential energy. Okay, so do include this point as well. I hope you all are writing about the different forms of energy that exist. So I told you to write five different forms of energy, and those forms of energy are light energy, heat energy, chemical energy, electrical energy, or mechanical energy. These are the five different forms of energy, and when it comes to mechanical energy, they are like mechanical energy is a sum of two different energies, that is kinetic energy and potential energy. Okay. After this we will be discussing on what exactly kinetic energy is. Okay, and we will be calculating it as well. So see, what is kinetic energy? Object in motion possess energy and can do work. So any object that you have around you, and if that object is in motion, okay, it means it has energy in it and it can even do work. Getting it, everyone? So object in motion possess energy and can do work. So this energy is called kinetic energy. Got it, everyone? I'm repeating it again. Object in motion possess energy and can do work. So this energy is called kinetic energy. Okay. So according to this, like when it comes to kinetic energy, we already know the formula that force is equal to mass into acceleration, right? This is the formula for force that we have, and we also know that work is equal to force into displacement, right? And from the second equation of motion we even know that v square, if you remember, you have solved so many numericals in the last lesson using this equation. V square minus u square is equal to 2as. Got it, everyone? So when we rearrange this equation, okay, this equation when we rearrange for calculating displacement, the rearrangement will be like v square minus u square upon 2a, right? So what we have done, we have just rearranged this equation, taking s over here, then v square minus u square is over here, then what is left? Only 2a is left. So we have divided that because over here it was in multiplication. Now we are going to substitute that in this value. So if I write this again, w is equal to f into s. Now we know that f is mass into acceleration, ma. So m into a, right? And when it comes to s, we have even came up with the formula for s, right? That is v square minus u square upon 2a. This is the formula, right? So now we can say, or we can come up with the formula that kinetic energy is equal to, what will happen? This acceleration and this acceleration is cancelled, and we are considering this u, the initial velocity, as 0. So if this initial velocity is 0, we are just left with 1 divided by 2, that is half m v square, right? So we get kinetic energy as half mv square. Got it? How the you can say it has been derived. So for that you need to know the formula. Force is equal to mass into acceleration, and then you need to know this second equation of motion. So I want you all to quickly do this in your book, because this is again very important for you to know how to derive the kinetic energy. Okay. So you have to understand it properly how we have derived the equation for kinetic energy, that is Ke is equal to half mv square. Okay. After this we have like work energy theorem to discuss, which I will be letting you know in short. But before that I want you all to be very much clear with this kinetic energy part. I hope you all are done writing about kinetic energy. Now the next thing that we have to discuss is work energy theorem. So there's a statement that has been given by work energy theorem, that is the net work done by a moving body can be calculated by finding the change in kinetic energy. How can we calculate the net work, like energy work theorem? What does it states? That the net work done by a moving body, when a body is moving, and how much soever the work has been done by that moving body, we can calculate that work done by finding the change in the kinetic energy. So if you have to find net work done, so we will represent it as W NET. So it becomes net work done is equal to kinetic energy. This is going to be the final one. So we'll write F for final minus kinetic energy in initial. So what was the kinetic energy in the initially, and what was exactly it is at the, like what was the final kinetic energy, and you will know, like it will be half m, because over here we have the initial velocity, right? We are not considering the initial velocity 0. So net work done over there, the formula will be half m v square minus v u square. U square is taken because the initial velocity has some value, it is not 0 over here. So I want you to write that the work energy theorem states that net work done by a moving body can be calculated by finding the change in kinetic energy. And I want you all to write whatever I have like written. After this work energy theorem, we have the factors that affect kinetic energy. So we have three different factors that keep on affecting the kinetic energy. It includes mass, velocity, and momentum. Which are the factors? Mass, velocity, and momentum. Okay, so write this, that these are the factors that affect kinetic energy. Okay. I hope you all are writing the factors affecting the kinetic energy. After these factors, we have potential energy to discuss in short. Now, what is potential energy? You know, when the energy is been stored in an object, when work is done on it, that energy is called as potential energy. Okay, what is potential energy? Energy that can be stored in an object when work is done on it. That is potential energy. For example, I can say like stretching a rubber string is a perfect example for potential energy, right? So you can write that energy can get stored in an object when work is done on it, and that energy is known as potential energy. Okay. Now after this, like after potential energy, we have like conservation of energy to discuss in detail, which I'm not going to start with today. But remember, like the total energy is always going to be equal to kinetic energy plus potential energy, right? So in conservation of energy, we are going to discuss on that as well, where you should be knowing this basic thing, that total energy is equal to kinetic energy plus potential energy. Okay. So now I'm going to show you the lesson, like what are we going to actually discuss in the lesson. So we will be starting our discussion by discussing on what exactly work is in short. Okay, then we'll discuss on that not much work in spite of working hard. So like we'll be discussing on different concepts over here. Okay, after that we'll discuss on activity, like this activity 11.1. Now we have many different activities in the lesson, so make sure whenever we discuss any activity, you revise it during that time, because that is very important. The revision is very important, right? Then we will discuss on the scientific conception of work, which is again very important. In detail we'll be discussing that. Then we have an activity to discuss along with that. Okay, then after this two activities we'll be discussing on work done by a constant force. Okay, then after this work done by a constant force, we have this example again to discuss. After this, like we will be discussing on energy in detail. Okay, what we will discuss on, we'll discuss on energy in detail. Then we have different exam like activities to discuss. We have forms of energy to discuss in detail. Then after forms of energy, we'll be discussing on James Prescott Joule, who exactly he was. We'll be discussing on kinetic energy in detail. Now you know like how we came up with the formula of kinetic energy, that is half mv square, right? So we'll discuss on kinetic energy in detail. Then after kinetic energy, we'll discuss on this activities and examples. Okay. Then after that we will be discussing on potential energy in detail again. Now kinetic and potential energy are two important forms of energy that we will be discussing. Okay, so you can see there are so many different examples and activities that we need to discuss while we study the lesson, right? Then after discussing on 3-4 activities, we will be discussing on potential energy of an object at a height. Then after that we'll discuss on this examples, and then are various energy forms interconvertible, like can you convert the different forms of energy, are they interconvertible or not, we'll discuss that in detail. Then after that we'll discuss on law of conservation of energy in detail. Okay, for that I told you, just remember that the like total work is equal to kinetic energy plus potential energy, right? So you should be knowing that. Then after that we'll discuss on this activity, and we'll discuss on the rate of doing work. What we will discuss on? The rate of doing work in detail. Then we have 2 3 activities, and then we'll discuss on the commercial use of energy. What we will discuss on? Commercial use of energy in detail. Then again we have activity, and lastly we have the summary discussion for the whole lesson, work and energy. But along with the summary discussion, we have like 21 exercise questions to discuss at the end. Now I'm going to show you all the questions one by one. Make sure you go through them properly. I hope you all are going through the exercise question that has been seen, like that I'm showing you on screen. So this is the last question that we will be discussing for work and energy, and I hope whatever we discussed today in this part for the lesson like work and energy, this was the introductory part for the lesson. So I hope you might have understood like what exactly we are going to study in the lesson, right? Because you understanding and knowing it is very important. So I have introduced many important terms, many important concepts to you all today in this part, which we are going to study all of them in detail in the next part. So make sure when we are meeting the next time, you all are revising it properly so that it becomes easier for you as well as like it is easier for both of us to know, like for you to know the concept or for me to explain it, right? So I'll end the session for now and I'll be continuing with the like lesson in the next part. Thank you everyone.